Welcome to my channel. Ben Franklin rides again. Some of you may remember that this poor African twin was called into sidecar duty for desert riding from almost day one of its existence. This was, of course, against Uncle Saturio's will, as his lawyers clearly state in the owner's manual for the bike. Nonetheless, I wanted an adventure sidecar rig that could go all the places a Ural could, but do it a whole lot faster with a few more creature comforts. I had an old crook build the sidecar and attach it to the Honda. I then spent the next 3 years remanufacturing about everything that his team built on the rig, but having a blast bouncing it around out in the Arizona desert. However, about a month ago, I began noticing a peculiar clicking noise on low speed braking and turns. I finally decided to find it and fix it, so I rode around the subdivision, braking and listening. I eventually noticed movement when looking at the steering stem and the front edge of the gas tank. Oh hell. I brought it into my shop, pulled the gas tank, and found the damage in the opening photo montage. The top two frame tubes were broken and completely detached from the steering head. A crack ran about 10 centimeters down the main gusset that they joined to the steering head. After a lot of thought, I came up with a hypothesis about how this all happened, other than, hey dumbass, you put a sidecar on a bike. About 2 years ago, I hit a rut crossways of a dirt trail that had washed out about a foot deep and about 2 feet wide. This was at a time when I was still running the springs on the front end that the old crook had selected for the rig upon its original build. They were 29 newtons per millimeter rate springs. For reference, the correct springs that I now run are 60 newtons per millimeter spring rate, a little over twice the spring rate. When I hit the rut at some speed, it bottomed out hard, so hard that it broke the bracket off the front of the steering head that holds the 10 kg instrument pod and fairing nacelle onto the frame. I built a gusset for this bracket and TIG welded it back onto the steering head, where it has lived happily for the past 2 years. What I think happened though was that hard bottom out also jammed the front wheel back towards the frame and started the crack in the frame tubes. It then progressed slowly over the past couple of years and 40,000 miles or so to the point seen in the opening montage. At least that's my story, and I'm sticking to it. Let's take a quick walk around the rig before we talk repair strategy. Okay, so what to do about all that damage that you saw in the opening montage? Anyone intelligent would probably call their insurance company and describe the incident and have the outfit totaled out. However, I'm not that smart. A different, even smarter person might buy a used frame off of eBay for a couple of grand and move everything over. However, I'm not that smart either. I think a new frame would still be weaker than is needed for the abuse that I like to put this thing through. So, I decided that this would eventually be the $6 million sidecar rig. We have the technology to build it back better, faster, stronger, just like Steve Austin. Really, I figured that I can TIG weld good enough and that a new frame would not solve the problem. I got to thinking about the force vectors applied to the steering head and came up with a series of gussets and braces to apply to the frame after welding the fractures back up. So, proof that I'm an optimist, if you need any, is that I went ahead and did a valve service on the engine prior to sparking up a TIG torch. Things were very happy under the valve cover. Clean, no deposits after 41,000 miles. Only one exhaust valve needed a slight adjustment. Then I got a little more serious and cleaned up the areas to be welded with a flapper wheel on an angle grinder. Put an alignment jig on the two bike wheels and then aligned the frame up straight and started tack welding to make sure things stayed nice and straight during the welding process. Welding thin wall tubing to thicker gussets posed a few challenges, but eventually got it figured out. Also noticed that Uncle Sochurio's robots missed a weld or two to the main gusset on the left side too. Not nice. Probably did not help with the strength of the rig. Once the top was aligned and in position, I worked my way down both sides of the fractures with an angle grinder and eventually a Dremel tool to get all the powder coating out of the weld area and create some nice fresh metal to weld to. Next, I decided that FAD, foil aided design, was the next step beyond CAD, or cardboard aided design. I used thick aluminum foil to make templates for gussets and braces that would fit around curves, but could be flattened out onto flat surfaces to cut out the unformed gussets. Holes in the flat plate are for plug welds to the frame. After welding the top edge of the second gusset, I heated a narrow band of the flat gusset with oxyacetylene to cherry red and formed it around the frame with a body hammer. The flat stock is about 3 millimeters thick and aerospace grade steel. After painting the welded up and gusseted frame, I found that I had made a little whoopsie. I did not allow for the encroachment of the front of the airbox into the space I grabbed for the new gussets. Not a big deal. Relieved the nose of the airbox to fit the available space, then used FAD again to create an aluminum plate to form over the hole that had been created by sawing off the nose of the airbox. Glued and screwed it in for an airtight seal. Reduction of airbox volume was nominal, but you can hear a little less resonation on wide open throttle. Does not seem to affect performance in any noticeable way though. Once the frame was welded, then considerably reinforced, I turned my attention to how to relieve some of the stresses that hard riding puts on the steering head section of the frame to begin with. On either hard braking or impact with rocks, ditches, and other such obstacles, the leading link tends to push the front wheel backwards towards the frame. On hard cornering on pavement, the sidecar puts pressure as a side load on the front wheel, which is transmitted to the steering head as a twisting force. I decided that BMW's telelever suspension has some merits in absorbing some of these types of forces and transmitting them to a stronger part of their frame. I did not need to make it float though, like a telelever. Just a fixed brace would do, with a ball joint where the front fender mount pivots. I shined a laser through the steering stem, found the pivot point, and drilled it for a Heim joint that I had left over from some sidecar modifications. The other triangulated end was shaped and welded to the sidecar subframe, where it attaches to the down tube and the engine mount. This should take some of the force for braking, impacts, and hard cornering and transmit it to a stronger part of the frame without twisting the steering head. So I found the problem on a Sunday, then 2 weeks later took it on a maiden voyage after repair. Started out gentle and now, over a couple of weeks, have worked it back up towards handling rougher terrain. Total cost of the repair was about 40 hours of my time, including a valve adjust and coolant flush, since I needed to pull the radiators to get them out of the way, and about $63 worth of argon shield gas for the TIG welds. Most of the materials, other than a couple of tubes of welding rods, came from my scrap pile. Is it good enough? Well, I guess time will tell. It sure feels good now, and is held up over some rock crawling last week. Feel free to comment. Trust me, my feelings won't be hurt. friendly professional welders have already supplied me with this meme a few times. Thanks for watching. Until the next time when Ben Franklin rides again.